I don't know if you can tell, but I'm really excited about this module. I've been waiting for it for all the recordings that I've been working on. App service plans and app services combine together in an area of platform as a service or PaaS. And I strongly believe that this is the sweet spot of organizations' ability to move to the cloud where they're going to get the best return. As I said, I'm really excited about this module, and I hope you will get that enthusiasm and see the value it's going to bring to your organization. As with everything in life, there's a yin and yang or a balance. I want to get this off my chest before we get into the feature. There are two things, and Microsoft's been great about certain things, but our naming conventions sometimes can get a little confusing. As I speak through this module, you're going to hear it sounds like the same thing, but an app service plan is a parent object. I've said this in other recordings, that child objects inherit things from their parent, and we have a parent-child relationship. The app service plan as a parent object has, guess what inside of it? An app service. They're not the same thing. So when I'm talking about app service plans and I say app service, oh, he just forgot the plan. No, they are separate, and I have to use the proper naming convention. It would be easier if they were different, but as I go through this, please don't get those two words confused. My name is Bob Tickleman, and I'm really excited about delivering this module to you. Let's get into it. App service plans as a parent object that then can have multiple app services inside of it becomes this founding component where a lot of the configurations and the value that you're going to get from an app service and the platform as a service capabilities provided by Microsoft. We are going to take on the responsibility of the vast majority of the infrastructure requirements that you need to run your applications. Because at the end of the day, I'm going to say the vast majority of companies that I've worked with over the decades is they don't even care too much about the applications. It's the data that the applications give them access to. And I can tell you, most companies didn't care about the operating system that their applications ran on to give them the data that they cared about. And this is going to allow you as an organization to now relieve yourself from some of the challenges that you've had managing the infrastructure and then to deliver the applications and the data that the companies really require. So we're going to take a look at all the different components that make up an app service plan. We'll have a separate section that we get into the app services that fit within the plan. The app service plan as the parent object is what's going to control the resources that are going to then be shared by the app services that exist within the plan. So we'll take a look at the performance, the price, and the features that come along with this. What I want to do, though, is give you a visual representation of what this is going to do for you. So I'm going to go to a whiteboard session, and then we'll come back and look at the features and then demonstrate this in the actual portal. If you've been watching some of the other recordings, you've probably seen this picture before. When we talked about the virtual machines, as a user accessing a virtual machine, it would come through the ARM layer, however you get there, that would then connect to the resource providers. And it was up to you to then build and patch an operating system that you would then put your application on. The app service plan is a fundamental shift from that process. Now, what you're worried about is your app that you need to deploy to some resource. Now, what you're going to be able to have with the app service plan, and what I'm trying to represent here, in other pictures you've probably seen I build these things called scale units with nodes. What Microsoft is going to do at the infrastructure level, we are going to build at scale thousands of virtual machines hosting both Linux and Windows operating systems that you can then consume. You don't have to build them to install your application. They're built by Microsoft to recommended standards. They're rigorously protected and locked down and secured and patched and maintained, all of those pieces. So you don't have to do that. You can just go and get the resources from a Windows or Linux server to then deploy your application to. So what you're seeing here is I can take, maybe this machine has got, let's say 24 cores, and it's got 256 gig of RAM, just as an example. You can take your application and deploy it into an app service plan that then could take some or all of the resources. Maybe you only want 2 cores. and maybe you only want 8 gigs of RAM. Your application then could be put into that and run in protected memory address space on that machine. The operating system is patched and maintained by Microsoft, and all you have to worry about is the consumption of the resources or portion of resources that you need to deploy for your application. So as you come through, and then we're going to take a look at different ways you can have an entire machine dedicated to you that you can run multiple plans on. You can have it in a shared environment. Now, it is protected memory, so if you're on a VM like this is running and you've got some cores and somebody else is on them as well, you're not going to conflict. Microsoft guarantees that you won't have things called noisy neighbors. So if you are allocated 2 cores with 8 gigs of RAM, you will get 2 cores and 8 gigs of RAM, and possibly sometimes even more, but you will never get less than the prescribed 4 resources you're working with. So the app service plan is that determination of performance, price, and features that you're going to get, and we'll take a look at that as we go through this. When you take a look at the pricing plan and the features that come along with it, and as I've said in other recordings, from an exam perspective, here's one of those eye-winking moments, a chart that compares the different plans and the features that come with them. Now, don't try and memorize the entire chart, but I want to focus on several features. You want to take a look at where does auto-scaling take place, and where do you get this feature called deployment slots. I'm going to show you in the graphical interface, they call them staging slots. It's the only place that I've ever seen in all our documentation that they're ever called staging slots when I go to the graphical interface. They're deployment slots. Everybody talks about them as deployment slots. Most of the documentation talks about deployment slots, but if you ever see the term deployment slots and staging slots, they're the same thing. The breakdown is deployment slots have 2 major breaks. Across the free, the shared, and the basic plan, you do not get this feature, and I'm going to explain what that is. Within the standard plan, you have up to 5, and for the premium and isolated, you get 20. The kind of question that you might see is, you are currently running an app service plan that has 5 deployment slots that's working with this. You have a need to expand to other deployment slots. What would you need to do? Start another app service plan. Upgrade your service plan from standard to premium. And so they're going to give you some of these options. And if you've never seen this chart, you might not know where that breakdown is. The other one is, where does auto scaling come in? Again, there's no auto scaling features, which we're going to spend quite a bit of time on in this recording, in the basic, shared, and free. In the standard plan, it is supported across premium, standard, and isolated capabilities. Now, what will happen is it manual, is it automatic scaling that's going to come with this? So those are going to be some of the differences. But we're going to take a look at each of these plans. Each has different features, and I'll be doing that in the graphical look, and I'll get deeper into it when I get there. But you understand that there's a variety of plans that you're going to be able to use to the app service plan. One of the features, and one of the, I think the powerful features, is the ability to provide that scaling. In a previous recording, we talked about the scaling out and scaling in, increasing the number of instances that you have to provide that set of resources. Now, we can also scale up and scale down. You'll see that, and we talked about that in the virtual machine environment. If you need more cores, if you need more memory, you can scale that plan up. But there's sometimes where the resource constriction isn't just by giving it more resources. I just need more of them. That's where you're going to get scale out and scale in, sometimes referred to as horizontal scaling. So I'm going to go and describe this to you, talk about some of the features, and then we're going to get into a chance to take a look at that in the graphical interface. As you saw from the previous screen, there was 2 types of scaling. Manually scaling, where you can dynamically expand or contract the number of resources being allocated. The automatic scaling provides several options as well. So I want to talk about auto scaling and how it works, and it's based around these things called rules. And for me, this becomes one of the biggest challenges that I've ever had supporting our customers in making sure that the desired results that they need are what they're getting. When you get into a scaling rule, and I'll be doing this in a few minutes when we get into the portal, you're going to get what's called a scaling rule. Now, we're going to use this rule more than once. So you have a scaling rule at a parent object. Now that rule can have multiple conditions in it. When you get into the graphical interface, you'll see that there's a little plus sign that says add a condition. So this is just one condition that you have. Within the scaling condition has a name. And then you can tell what kind of scaling do I want. Do I want it scaled based on a metric, some attribute, CPU utilization, network throughput, disk capacity? There's some metric or numerical value that can be measured that will then indicate when I should scale out and scale back in. And you can scale to specific instance counts. Now I'm going to scale based around metrics. That's where I'm going to focus around. You will then have your scaling rules inside of the scaling condition. We have scale out rules and we have scale in rules. Microsoft recommendation, I'm winking moment for those of you who are looking for the exam, is Microsoft recommends you have at least one scaling rule per scale out and scale in. I'm going to give you my recommendation in just a minute. When you go through and create the scaling out rule, you can set what the metric is. This is going to be percentage of CPU, and then what is called the threshold. And then what is the scaling condition that you're working with. Now, in many cases, and the documentation, the way it presents this is most of them will teach scale out when CPU is greater than or equal to 70%, add 1. That sounds great. If you have one and it's over 70%, you get another one, you've got 2. You're looking pretty smart. If you've got 2, you add 1, you've got 3. You're still looking pretty smart. What happens if, not maybe here in applications, but in virtual machines, because remember the same scaling rule, if you've come from that VM module to here, you can have up to 1,000 virtual machines in a scale set. Having 1 VM and then going to 2, you've doubled the capacity. Again, you're looking pretty good. But what happens if you have 500 VMs and you add 1? You're not adding very much capacity. So this is where I'm going to give you my recommendation, and you're seeing it here on the screen, is that I can create multiple conditions to indicate when to scale. And so this says if it's greater than or equal to 70% CPU, increase by 10% or increase by 1. So if I've got 1, 10% of 1 is 0.1 or 1, I'm going to give you 1. If I'm at 20, I could either add 1 or I can add 2. Microsoft will never under provision. I've talked throughout these series of recordings that there's some golden rules you might want to remember. Permissions are cumulative with the exception of deny. Child objects inherit things from their parent object. All of them still are playing here. And here's a new one that has never been spoken before. Microsoft will never under provision in a scaling condition. So whatever is going to yield the greatest scaling condition or the number of units to have in place, that is the one that will be picked if there's multiple choices, and I'll show that in just a minute. Microsoft recommends you have at least a scaling rule to scale it out and to scale it back in, because you just don't want it to scale out and stay there. You want a condition to scale back in. So in this case, when it is less than or equal to 40%, you can decrease the number of devices. And again, I put both in. Now I do want to point out, you'll notice that in the scale out, it's an or. When it's one or the other, it's going to scale, but the scale in condition is an and statement. So you have to be a little bit careful. It's not scale in by 1 or 10. It's going to have both of them be the scaling condition you're working with. A scaling condition has a minimum, a maximum, and a default value. What does it start with by default when the services start up? What can it grow to as a maximum? And what will it never go below? So each scaling condition has its scaling out and scaling in components, never to exceed the maximum or the minimum number of values that you're working with within that scaling condition. Now, how does this come out into play? When you have in a scaling rule, I have multiple conditions. So this is condition number 1, and I've got condition number 2. I can scale this out based on a metric, and there are usually 3, I'll say 4 different ways that we look at this. I can scale it based on a metric. I can scale it on a day of the week. I can scale it on a day of the year, or what's called an app metric. I can have up to 4 or more different scaling conditions. Say I'm a retail operation and that I'm busy usually Monday to Friday. So I want to have a specific scaling happens Monday to Friday. I'm not busy on the weekend. But I'm always going to have some metric, because what happens if I have some unexpected activity? My retail operation that I've planned for over a period of time and years of knowing my business, I know Monday to Friday I'm this busy. But let's say I have a product that appears on some celebrity's favorite list near Christmas time, and all of a sudden on the weekend my website gets absolutely flooded. I don't want to have that crash or that lost sales opportunity. So I'm going to always have a metric that says, hey, if all of a sudden you get this unexpected growth and you're only planning for a small amount because it's the weekend, don't just stay there. Grow to meet the demand that you're working with. Now, I go to the day of the year because, remember, as a retail operation, globally more and more people are recognizing this period of time called Black Friday. In late November every year, retail operations expand significantly. So what I might want to be able to do is to plan for days of the year that might have significant growth that I can plan and work with. And for the specific metric, now this is unique to the app service plan scaling. This does not apply to the metrics for scaling of the virtual machine. So if you've come here from the VM model, this is something that's only available in the app service plan. Because we're running the application inside of the app service plan, it could emit metrics about what is the number of clicks on the loan application page. So you're going to be able to get telemetry information, what's called app data or app insights. I can get application insight data specific not just to the CPU or memory or network capacity or disk. I can actually look at the performance of the application and potentially scale on criteria or metric values of the application itself. Now, when I get to the demonstration and actually show it to you, I want to show you something because it's not reflected here on the chart. When you build the rule, you want to have a couple of other things that you're thinking about. First and foremost, there is a period called cooldown. You'll see that when I get to the graphical interface, it says, hey, over, and these are the default values, over a 10-minute period measured in 1-minute increments, when the scale of this, in this case, is greater than or equal to 70%, we're going to trigger a scaling event. So let's say I just turn this on at 9:20. I have 2. I'm going to draw them as VMs. These could also be app service plans. Doesn't matter whether it's an app service plan or VM, you've got 2 of them. And it says when I'm greater than or equal to 70, add 2. When I'm less than or equal to 50, remove 2. Let's say that I'm 0 busy at 9:01. At 9:02, I'm at 70% busy. I'm at 60%. I'm at 70. I'm at 80. I'm at 80. I'm at 90. I'm at 90. I'm at 100. I'm at 90. At 9:30, my 10-minute window says check to see if I need to scale. In this case, the average of all of those 10-minute intervals would indicate that I need 2 more of whatever it is that I have. Then what happens is that 10-minute window starts to walk and it starts to slide along. Now, app service plans, and one of the benefits of them is they spin up nearly instantaneously, because remember, the infrastructure has been pre-built. All you're doing is going to a machine that's already built and deploying your application to it, which happens in matters of seconds. If this was virtual machines, it could take potentially minutes to build the virtual machine infrastructure and post the operating system, get it all up and going and working properly. So what happens is we're still now, we got a load balancer, we were over 70%. Now several things are going to happen. It was at 70%, and we added 2 more. Let's say no additional work came in. Now I'm at 35, 35, 35, 35, just taking the 70 and splitting it. So now what's happened is, now I'm at 35%. I do not want to trigger, because now what would happen is they're all below 50%. It would remove 2. This is where the cool down period is, to say before you do another scaling out or scaling in, we're going to let things kind of normalize for a bit and kind of settle in and get comfortable before we do another evaluation. Now, I'm going to give you 2 hypotheticals. Let's say nothing happens for the next 5 minutes and we stay at 35%. At 9:35, we trigger the next scaling because the cool down now has exhausted, and it will now get rid of those 2. These will jump back to 70%. And at 9:40, it will add 2 more, because you've created what's called a race condition. Because your scale in has caused the condition to scale out. So when you pick these values to scale out and scale in, you want to make sure that the condition, if it were to scale out, is not going to create a race or a condition to scale it back in at the next evaluation. So you may make this, say, 30%. Give it some time to take the extra workload that you're working with. Let's say that work did come in and we're now at 70, 90, 80, 70, 80. You won't get the next 2, again, still to 9:35, then adding 2 more. Or if you had 10%, it'd be 0.4 or 5. So that's the whole rules. Now, when you have multiple conditions, and let's say that at the end of the evaluation of condition number 1, let's say you should have 10, and on the evaluation of the day of the week, you should have 30. The one that wins is the one that yields the largest number of net resources at the end of the evaluation. So if you have one for day of the week, day of the year, day of the month, whatever it is, all the rules are always evaluated within the set of the rules for its minimums, maximums, the scaling conditions. And then when each of these numbers are evaluated, the largest number is going to be picked. Now, that's not in any of the content, but I think as an administrator, it's important for you to do, because if you misconfigure this is where you're potentially going to run into a challenge and not get the performance you're expecting out of your app service plans. So there's a detailed discussion about scaling, what it is and how it takes place. And as I said, I'll be doing some of this in the graphical interface in just a few minutes. This is catching up with some of the book stuff about creating those rules and how to work with it. So I'm not going to go through this. I've already done this at depth with the whiteboard session. But let's go into the graphical interface and do a demonstration of these. I've said this in other recordings that there's several ways to do things. And like other components like availability sets and availability zones, you can pre-build them or build them at the time that you deploy something. I'm going to show you both again and see what the challenges are, but they can be done either way. I can build the app service plan beforehand, and you can see I've already got 2, so I can come in and create an app service plan, and it's fairly simple from its design perspective. It needs everything that we've talked about before: a resource group, a subscription. You give it an app service plan name, and what is that base underlying operating system? On that whiteboard that I did, remember that Microsoft pre-builds, I had nothing but Windows servers there, but there's pre-built Windows and Linux devices for you to be able to use to deploy your application environment to, using that app service plan that may be tailored to a specific operating system. So you can pick it. West US 2, 3. I'm going to pick a Linux platform. Now, you can explore the pricing plans, and I want to spend a few minutes here. We talked a bit about it. So remember, it's going to have resources allocated to it as well as feature sets. And so here is the hardware itself, and so you can take a look at the different plans, how many vCPUs or cores you're going to be allocating to the plan, how much memory is the plan going to get, remote storage capabilities, and is scaling available. You can see scale from 3 to 30 from an app service plan. You take a look at these different plans. So that is from a resource perspective. When we take a look at the features tab, again for each of the plans, do you have auto scaling? Not available. Some are manual and some are rules based. That's what I was showing you. Do they provide daily backups? We didn't talk much about that, but there are some that are planned. Now, I would say this does not circumvent you doing your own backup plans. This is going to be at a Microsoft schedule that is part of the plan that we back up what's going on, but you still may want to have your schedule backup processed. Now, there's that word, staging slots. This is that one that said drives me a little bit crazy. This is the only place that I've ever seen across all of our documentation that ever calls them staging slots. Every place else calls them deployment slots, and from here on, you're going to see it referred to as deployment slots, but they're the same thing. Okay? And which ones have none, which have 20, and which ones have, if I go down here at the bottom, you'll see some have 5. So you can build an app service plan beforehand, or now I'm creating an app service. Remember, an app service exists inside of an app service plan and will consume and share possibly with other app services in the same app service plan the resources allocated to it. I come back in and now, very similar to our storage accounts, we have to have a globally unique name. And you're seeing there's this switch here that as I start to type something, it's going to put in an appended value to give it that unique global standard you're working with. If you turn this off, that works, but if I turn this one off, it's going to come back and saying that name's not available because globally someone else is using that name. Then I get to pick the application environment that I want to deploy for the app service plan so that my app can be supported. And we have a number of currently supported runtimes. Now, I want to stress this because we only support currently supported versions of platforms, whether they be Windows, so it's Windows 2005, 2022, current versions of Linux, but also the current versions of these runtimes. We see that we've got .NET, we've got ASP.NET, we've got Java, Node, PHP, Python. So all the major platforms or environments to run your application are going to be available to be deployed to this underlying operating system. Now, when you take a look at this, you'll see that some of these platforms support Windows, Linux, or both. So it's going to need a platform from an app service plan to be able to deploy this web app to that I'm working with. So if I pick something like .NET, you can see it can run on either a Windows or a Linux operating system. ASP.NET, on the other hand, only runs on Windows plans or Windows operating system, so it has to have a Windows app service plan. And some of these only run on Linux. So depending on what you've got, what operating systems you need, all these configuration values, especially if you're an infrastructure person, you may not know what is being required. So make sure you get those requirements from the application developers. I picked the region, and so an app service plan, very similar to the words I used when we talked about storage counts, are a regionally based unit of resource allocation. So if I go to US West, the resources are going to come from US West and the apps have to be deployed into US West. If I'm going to deploy into any other region, I'm going to need an app service plan in that region to support that environment. And so I can either pick one that's already built, so you saw that from the previous tab that I had, ASP.-app service plan for my RG demo, or I can create a new one. New plan. And it's going to then bring up a screen that will allow me to go in and pick some of the plan characteristics that I'm going to be working with. I get the pricing plan that I want to work with. There's some pre-built, or I can go look at those plans that I've already showed you. So that gives you the basics for the app service plan so that we can deploy the app services into it. Let's return to the presentation. I've showed you the major configuration attributes of the app service plan. Now, I didn't do the specifics of the scaling. I'm going to do that in another recording when we take a look at the deployment slot. So while it wasn't done here specifically, if you're looking for that, you're going to have to jump off to another video. The app service plan as a platform as a service relinquishes your need to have to deploy, build, maintain, secure operating systems to create the runtime environment that your applications and data need to run for the enterprise. I believe that this is a very compelling reason that more and more organizations would have to look at as ways to significantly reduce cost and overhead of running their environments. So hopefully you now have seen that compelling reason, and we'll now look at other app services to then run your applications that you're going to use for your enterprise. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.